Getting to Pluto, one of the things that surprised me as I was reading about New Horizons was that it didn't stay there the way that like Juno is. And I was wondering if that was because of the speed. I think I read that it flew past Pluto at upwards of 50,000 miles per hour. Is that just too fast to stop and orbit at that point?
No, it's not too fast, even for our current technology, but it's not practical. But let me start and say the first stage of exploration of all the planets is to do flybys. They're simpler, they're less expensive, they get the lay of the land, and then you send in a more expensive probe where you understand the basics so you can send the right instruments. So
I
we
see.
always start with the less expensive flyby as the first stage. But secondly, we wanted to get to Pluto as quickly as possible. It's very, very far away, 3 billion miles. And the spacecraft traveled at this enormous speed that took it to the moon in 9 hours and did that 24/7 for 9.5 years, nearly a million miles a day, 365 days a year for 9.5 years to get to Pluto. And when we got to Pluto, we were moving very fast. And if you tried to come to a stop, you could not do it with the kind of propulsion technology on board New Horizons. Think about it. It took a rocket 225 feet tall to launch New Horizons. It would take a similar sized rocket to bring it to a stop so you could orbit.
Mm. No, that makes a lot of sense.
We have other technology that's it's called electric propulsion that makes that more efficient. And people have now designed follow-up missions to New Horizons with orbiters that have never been built, but we know what to do, how to build them. And it turns out they take about 20 to 25 years to reach Pluto, because if you're going too fast, even that better propulsion technology can't bring you to a stop to get into orbit. So you have to limit your speed so that you can have enough braking to get into orbit. In the case of New Horizons, that wasn't the objective. The objective was to get there and do it as quickly as possible so that we could get the data back as quickly as possible. And so the spacecraft didn't have to survive any longer in space than necessary to keep the cost down. So the whole objective was to do a flyby. And had we tried to do an orbiter, we probably never would have had the project because it was not affordable.
I hadn't realized that there was this flyby then probe model to better fine tune the instruments that you send in that next round. But that makes a lot
So
of sense.
take a look at Wikipedia or anywhere else, a textbook, and you'll find the first mission to every planet and to every other kind of body like comets and asteroids always begins with flybys. There's not a single exception, even the moon.
So then, how close did New Horizons get when it finally arrived at Pluto, and how long did it manage to collect data before it zoomed on?
Okay, so we got about 12,000 kilometers or almost 8,000 miles from Pluto. We could have gone closer, but we determined that was the optimal distance, because if you went too close, things would be blurred as you went by very quickly. It's sort of like let's say, think of Top Gun. If you had a supersonic fighter and you were doing not bombing but reconnaissance, say you were flying by a building. If you come too close, the images are going to be blurred. The same speed farther away makes for better results. So there's an optimum between being too far away and not having good enough resolution, and being too close and getting too much blurry. We figured out that math, and that was the answer: 12,000 kilometers. Um, the Different kinds of missions use different kinds of science. It's not just cameras, or even just cameras and spectrometers. Sometimes we take instruments that sniff the atmosphere, so we need to get into it so we can get the compositional samples or what have you. In the case of New Horizons, it was really about mapping, because we didn't have good maps. We didn't have pictures of Pluto that could show us really anything, even the basics, because it's so far away. We started studying Pluto the first year after we launched from Earth. And we continued to study Pluto even years after we were at Pluto. But all the real important data came when we were close. in the roughly 10 weeks before the flyby, where we could exceed the resolution of the Hubble Space Telescope. And every day it got better and better until closest approach, and then we were receding again. So almost everything that's important that we learned is in those 10 weeks, and most of that is in the few days right at close approach where we were closest.
Yeah, when I saw and read about the 12,000 kilometers, I was very surprised by that. I thought, oh, maybe if you got closer, you would lose speed or something like that, and that would hinder the trip out into the Kuiper belt and beyond. But no, this makes total sense, especially when you put it in the example of the fighter jet, that this is the optimal distance for the best measurements.
We did a big what's called a trade study, where we traded the kinds of science we could do with the instruments we have, and looked at all the science for all of these 7 instruments on board, and how well they could study not just Pluto, but also its 5 moons. And Dr. Leslie Young ran that study. It took months because we had to model the performance of 7 scientific instruments studying 6 different objects. So that's 42 combinations of things. And then vary those parameters at distance A, B, C, D, E, F, G. What do we get? And some instruments are better at one distance and some are better at a different distance. And we tried to find the optimal. So we created a scoring system in which we could, the camera might do better here, but the spectrometer there, and the other instrument at some other distance. And yet at every distance, each one of them could teach us new things. So we created a numerical scoring system and just racked it up and determined that this 12,500 kilometers gave the best overall result. And then we nailed, we went exactly where we said we were going to go.